All right, so we are going to do the physical changes and chemical changes lab. So there are going to be a series of 8 different like mini experiments that we'll be doing. So the very first one is we're going to take table sugar and we're going to take some before observations. So I'm going to go ahead and hold that up. You can see the sugar. So go ahead and pause the video if you need to take your observations, just regular table sugar, okay? And what we're gonna do is I have a flame and I'm going to put it over and I want you to take observations as it's heating up. Notice what it looks like on the outside of the test tube, on the inside. You're going to take observations before and after. And ultimately what we're going to be figuring out is by taking regular sugar, no water added, nothing added to it, and just heating it up, if the after effects, if it actually is a physical change or a chemical change. All right. So what it's doing is the sugar is actually, it's starting to turn like a brown color. So if you were to heat regular sugar up like this, you would actually find out it'll start like melting into a liquid. And it will actually turn into a brown like liquid. It's actually caramel. And so that's our first one. You can barely see it because my test tube is turning black. That's not the sugar. The sugar is turning like a brownish color, kind of the same thing. So you record your after observations. They said it's a really, really thick brown like liquid. Okay, see that. Now the second one, the second experiment we're going to do, and just follow down on the chart that you have there, is to take some salt, just regular old table salt, and to put it in a beaker. Okay, so I have just regular table salt in a beaker. So again, pause the video so you can take your before observations of what it looks like. So when you take before and after observations, the before observations is before you do anything to it. So if you have separate ingredients, what do the ingredients look like before you mix them together or combine them together? So this is just regular table salt, right? Now, what it asks for is to take a little bit of water. We'll take a little bit of water and to mix it up, okay? And the salt goes into solution. It dissolves into solution, okay? Now, the directions say to put it on some heat and let the water evaporate away. So when that is done and all the water is gone, so this is the after observations, this is what you get. Notice how there's no water, okay? I heated it up for about 2 minutes, honestly. All of the water evaporated, and this is what was left. Okay, you can kind of see it's kind of flaky, white, powdery, kind of flaky. So this is your after observations, all right? Your before was just the salt before the water was added. Then this was when you added the water. And then this is after you heated it. Okay, so take your after observations. And with those two, the sugar and then the salt, you'll determine whether or not that was each one of those was a chemical change or a physical change. Again, the difference between the two is the physical change is whatever you started with, you can get back after. Chemical change is where the before and the after are completely different, and the after, you can't go back to what you had to begin with. Okay, so kind of like if you take an egg and you crack it into a pan and you cook it, you cannot get the original raw egg back. That's a chemical change. Okay, whereas if I take an ice cube and I melt it in a cup on my countertop, I can take that water, put it back in the freezer, and I can freeze it. Okay, now the next one is we're going to take some magnesium ribbon. Now this one, I'm going to stand back a little bit when I do it, but this is just a piece of magnesium ribbon. So go ahead and take your observations before. It's kind of bendy. Okay, short, little shiny. So this is where you take your before observations for your magnesium. Okay. Right now, what I'm going to do, I'm going to take my little candle that I have again, a little flame, and I'm going to take the magnesium ribbon and I'm going to put it into the flame. I am going to warn you though, don't look directly at the screen, kind of look at the side of the screen if this works the way it's supposed to. Okay. So then the after, that's what the after is. Okay, so the during was that big flash of light and everything. By the way, that's where you get the white fireworks from. It's from magnesium, right? And this is the after. You have that like little powdery substance. Okay. All right, so that's number 3. That's our magnesium. The next one is to take a piece of zinc. So I have zinc, just a metal piece of zinc. So take your before observations for your zinc. Well, you have your before observations for your zinc. It is bendy. And we're going to do the same thing. I'm going to put it in the flame. So you saw the magnesium ribbon. What happened to that when you put it in the flame? Okay, made that bright light. And then it basically turned into kind of a whitish, grayish powder. So I'm going to take my zinc, same thing. I'm going to put it in the flame. You can see it's breaking off. It's kind of, it's almost like it's warping it. It's melting it a little bit. And get out of the light here. There we go. Okay. Push. So no flame. It does. It turns it a black color. Okay. I guess you can see that. It turns it a black color, and then it makes it kind of like fall off, but it doesn't turn into an ash. It doesn't make it disappear. It just turns it black, makes it really, really weak, and then it just kind of falls off. Okay. All right. So far we saw sugar, plain sugar that we heated up, and it turned into that dark brown goo, basically. We took salt and added water to it and mixed it up and then heated it up, and we got that white residue left on the beaker with no water once the water disappeared. I took a solid piece of magnesium ribbon or magnesium metal, and I just I put it into a flame, and it emitted a very, very bright light and then turned into a white grayish like ash. And then I took zinc metal, and with the zinc metal, I put that into a flame, and it just turned a black color, became very weak and started breaking off. Okay. So now the next thing I'm going to do is I'm going to take regular water. Okay, this is just regular water. And then this is calcium, and it's from an actual tablet that you can get from a health food store. And so what I'm going to do is I'm going to, first of all, I'm going to have you guys take your observations of the calcium. So go ahead and take your observations of the calcium. So white powder has a couple little chunks in there. I tried to make it some little chunks. And now I'm going to take the calcium and I'm going to add it into the water. And then I'm going to stir it up. Okay, so some observations. Now, one of the things is, you notice how I'm holding it, I'm checking to see if the temperature changed at all. And as I mix it up more, it is going into solution. The other thing is if I shake it up, notice how it's making bubbles. You see the bubbles? So take your after observations. And there is a temperature change. This is warm, not because I'm holding it, but it is actually warm. So I'm going to shake it up again. You can see it has like a froth. So take your after observations. It's not solid, it's still liquid. It has all those bubbles, and it is warm to the touch. So make sure in your after observations, you put that there are bubbles. It is warm to the touch. And then determine whether or not you can see through that. Can you see my face through that? No. Kind of milky white. All right. And we're based off of those observations, bubbles were produced, and it was warm to the touch, so there was a temperature change. And the fact that you cannot see through it anymore, it's not transparent like water is, that's gonna, those different characteristics are gonna tell us whether it's a chemical change or a physical change. Okay. All right, a couple more. The next one is I'm going to take, and I had to change this one up a little bit. I'm going to take some silver nitrate, all right? So you're going to do before observations for two different chemicals. One is for silver nitrate, so I'm just going to put a little bit of silver nitrate in a itty bitty little test tube. So in the before, put silver nitrate and record your observations for the silver nitrate. Right, it's just a clear liquid, doesn't have any color, it's transparent. Got it. Nothing fascinating. All right. Then so I have a solution of silver nitrate, and then I have a solution of sodium chloride. Sodium chloride, this is literally salt water. That's all it is. What we made earlier. Same thing as this. Let's try it. Okay. So I have clear liquid. Okay. This is a clear liquid. I know it's hard to see, but please put it before the sodium chloride. It is a clear liquid. They literally both look like water. Okay. Now, I'm going to take this and I'm going to add a couple drops of the sodium chloride to it. All right. I'm trying to do this so you can see. And I want you to watch very carefully what the observations are. So again, I'm going to start with two clear liquids. So you can see that white solid, that's a precipitate. That was not there before. That's a precipitate. So that will tell us whether or not that observation will tell us whether or not the mixture of sodium chloride and silver nitrate is a chemical change or a physical change. All right, so write your observations on that. That is a white solid. It is in liquid. There's still liquid in there. White solid. Okay, so take your after observations. There's still clear liquid. It does not dissolve. It's not soluble. It's just a chunky white marshmallow stuck inside there. Okay, so that's your after observations. No temperature change or anything. All right, so that's number 6. Number 7, I'm going to take some sodium bicarbonate. So I'm going to take some sodium bicarbonate, baking soda, basically. Okay, so take your before observations. Just regular old baking soda, Arm & Hammer baking soda. White powdery, a couple little chunks in there. Okay, and what I'm going to do is I'm going to take some, this is hydrochloric acid, it's very dilute. I'm going to take some hydrochloric acid and I'm going to add just a few drops to my sodium bicarbonate. Okay, so baking soda right here. Okay, let's see what happened. So I added the acid, and maybe you could hear a little fizz and you could see the bubbles forming and everything. There we go. Okay. So that's baking soda, regular old baking soda, and a little bit of dilute hydrochloric acid. Right, so I have bubbles that were formed. It does make kind of a milky solution. No temperature change. At that after observations.